All right, so if you've watched the other videos in my whole inspection series, you'll probably have noticed I never actually set up a dial bore gauge from start to finish on camera. And so I'm going to show you guys how to do that. And I wanted to isolate it from the rest of the video so it didn't take so long. But I'll show you right here. I have a dial bore gauge set, completely unassembled, ready for assembly. And set that off to the side. Just grab what we need. We are going to set up to measure the 970 hole that we did in the practice exercise. And we're going to need a 1-inch setting ring. So I'm going to get the print out. I'm going to measure this 970 through hole. Sorry about the lighting. I don't know how to fix that. 970 through hole plus or minus 5 thousandths from the title block tolerance. Okay. So we'll set up, we don't necessarily need to use a dial bore gauge for this, but because of the tolerance, but let's practice setting up. So we're gonna grab our dial bore gauge. It's at 970 hole. So this is the dial bore gauge for 2 to 6 inches. That is not the size we need. This is the dial bore gauge for 0.7 to 1.4, and we're trying to hit 0.970. So this is the one that we want. Here is our indicator that we're going to attach. And here is our set of bits that go along with the this size of a dial bore gauge. So we're going to have to choose an anvil that screws onto the back that will allow us to measure, set as 0 and then measure the part. So we have to pick the right size. Now you'll see on the guidelines 0.866, 0.945, 1.024. So these are some guidelines for which one you should start with. Personally, I don't actually know if these are maximum sizes, but because of the way I'm going to be setting this up, these are great for if you need to set up on one pin and move to another pin. You know, set up on this pin and 0, and then maybe put this pin in. We're not going to need to do that. I specifically chose an example where we can use the same pin for zeroing and measuring, which is what you should try to do. If you don't have a ring gauge that's close to the size that you're going to measure, you can also set up an OD mic. So we'll even do that too. So you can set up an OD mic at 970. And we'll save this for later. There's 970. Okay. Typically, I would actually set up some Joe blocks, so maybe we'll do that later too, now that I think about it. So, but let's start off with the easy way first. Maybe I'll show you a few ways to do it. So, we're trying to hit 970 and 1 inch for the calibration. So this 945 looks like a good one to start with. So I'm going to grab the 945 and we'll screw it in. And once again, this nub back here is what engages with the part. Okay, take a look at this other camera right here. If you can't see it well on the TV monitor there, it's hard to get it into focus. That little nub is what's going to measure, or what's going to ride on the part. So first of all, I'm just going to do a stroke check before I even attach the dial, and see, it's too loose. I don't have enough engagement for the 1 inch. It's just floating through without engaging at all. So that one's too small. That's fine. We'll just move up one size. Now I'm grabbing the one that says 1.024 maximum, or I assume maximum, number 5. And we'll try that. And this one barely gets in to the 1 inch. I can slide it up and down. Let's try the 970, because this is the hole we're going to measure. Won't fit this one. Okay. That's okay too. So this is definitely too big for this hole, right? This second pin that we did. So we're gonna definitely get rid of this. It won't fit. The last problem we had is it was too small. This one won't fit. Try not to do that. Try not to drop these. So now I go back to the one that I used before that was too small. And we're gonna add this spacer. This is a 40 thousandths spacer. We'll verify that with a caliper, 38 thousandths on the caliper, but again, 40 thousandths, the caliper may not be accurate. So, and in the end, it doesn't matter. We're going to zero on the gauge. We're going to zero on the ring. So we're just setting this up kind of remotely, loosely. All right, so I'm going to screw that on. I'm going to check my stroke again. Okay, this works well. It's sliding in, pivoting, and getting the type of engagement that I want. If I can. Yeah. All right, so now we'll try this one. And it is sliding in, pivoting, engaging. Both are engaging now. So I'm within the range of motion for both of these gauges, both of these holes. Now I've got to attach, or before I do that, this comes with a wrench. I'm going to tighten it down, just a very tiny bit of torque. Not much, really, that's it. Just a light pressure. Make sure it's snug. And we'll put this away. Now we have the attachment we want. Now we need to attach the dial. We're going to clamp it on here, but we got to get it through this cover. So I need to take the cover off. So there's a couple of Phillips head screws. You don't necessarily need the cover. It's just to protect the indicator, but I'm going to use it. And then we'll slide this on. Okay, and we'll put the cover back in, and it's kind of free floating. I'm gonna bolt the cover back on. All right, one screw. There's the other screw. And still move it a tiny, oh. It's a little too snug on one side, not snug enough on the other. All right, now once it's seated, getting the cover on is just whatever looks about right. The indicator is still free floating. I haven't secured it with this clamp. And again, we're gonna take a close look at our secondary dial right here. This is how much stroke. So we haven't engaged yet, or we just barely engaged here. And once we get back to the 0 over there, we've over traveled, okay? So this is our range of motion. Now we are gonna be measuring, we're gonna be setting our dial on something bigger than the hole by roughly 30 thousandths, right? The difference between 1 inch and 0.970. So this only has 50 thousandths of travel. Okay, keep that in mind, that if you don't get this set at the right level, you're gonna over travel. So what I recommend, if you're not sure, just aim for the middle. So I'm gonna apply some pressure and try to do this on camera. So there, I'm somewhere in the middle, and I'm gonna clamp down. Okay, that'll give me hopefully enough travel. It may or may not, I don't know. So now that I'm clamped in, got my end on. I'm gonna try to measure my ring gauge, and I'll try to show you this on the front camera. So once again, you rock it until it pivots. So it's pivoting right about there. And then when I keep rocking it a little too far, it pivots back. Oops, wasn't paying attention. So I'm gonna try to zero. I'm gonna rotate this dial until it reads 0. I'll show you on the big camera again what I'm doing. So I'm pivoting back and forth, and I'm just trying to get, I'm gonna rotate that dial until the 0 moves. So normally I would be looking dead on, kind of eyeballing it for now, so you can see it on the camera. I'm pretty close. I'm gonna finish it looking at it dead on. All right, I'm about 2/10 off. And I rotated it too far. That's not unusual. All right, I got 0. Hopefully you can see this on the front camera. The inflection should be over the 0, although it's hard to say if I can't see it. So trust me, when I'm looking at it, it's at 0. So now we got to look at the secondary dial. We got to take a look at this, where the secondary dial reads 0. Okay. So 0's there. The secondary dial is just a hair before the 2. Okay. And every rotation is 10 thousandths. Every full rotation of the large dial is 10 thousandths. So when we go to measure our part, unfortunately our dial has over traveled. So I'll try to show you that here. I've got the end in. Unfortunately we've over traveled. So I'm gonna show you as I try to straighten this out. It goes to 0, 1, it goes to 0, and then it over travels. So I'm not gonna apply any more pressure. I don't want to damage anything, but I'm not gonna get a good reading. So that means, unfortunately, I've got to re-zero the secondary dial a little closer to the 5. So I'm going to unclamp it, unclamp the dial, and adjust the pressure so that when I apply the clamp again, I'm a little closer to the 5. Now, if you've got a better technique, feel free to let me know. This has always worked for me, and I haven't used these all the time. I've pretty much used them when I have no other choice. I don't mean to sound like it's a gauge to be avoided, but it's not one of my favorites. It is very accurate though when you have a deep bore that has a tight tolerance. So I'm back at 0, and let's take a look at where we are. On the small dial, we're behind the 4, maybe about 3/4 behind the 4. We don't need to know exactly. We're going to count how many revolutions, because every revolution is 10 thousandths. So we're going to measure our part. And we haven't over traveled, so I'm going to show you on the main camera. And you can see the inflection point. Okay, we've got an inflection point. I'll show you on the secondary camera. And where's our secondary dial? We were just before the 4. Now we're just before the 1. So we've gone about 30 thousandths, although we haven't gone quite 30 thousandths. We've gone about 29 4/10. So 29 4/10, the way I was holding it from 1 inch, that would be 960 6/10. If I'm doing my math right, somebody verify that. I will try to 970 6/10. There, I verified my own math. I will try to verify that. Yeah, the calipers got me in the ballpark. Again, I always double check Just make sure I'm doing the math right. I'm not off by 10, I'm not off by 25, something weird, just because I can't do math. So, I mean, that's it. That's how you set up from start to finish. To measure a bore, you need to know what size you're aiming for. You need to find a ring that's relatively that size. That's one way to do it. If you don't have a ring that size, let's show you how to do it when you don't have a ring that size. I'm gonna grab my Joe blocks and we're gonna build a 970 sack. That's what we're aiming for. So in order to get to 970, I need to add 120. Here's the 120. Where's the 120? Here's the 120. We need to add the 120 to the 850. 850 plus 120 is 970, hopefully. So if you haven't seen me slide these together, you kind of go back and forth, twist, and that will give you a nice suction fit. 970. We have our 970 Joe block, and we're going to set our OD micrometer on the 970. And oh gosh, don't do that. How stupid, silly of me. I apologize. It's a little cumbersome doing these videos, and make sure you got a firm grip on your micrometer. I don't think it dropped too hard to really have damaged it. Unfortunately, I have done worse. So it's not really important what the scale reads because we're going to be zeroing it on these gauge blocks that we know are 970 because of the way we assembled them. So I'm going to lock that down, slide the gauge blocks out, and then apply the clamp. Okay, so now that distance is 970. And I'm looking for my micrometer clamp. My micrometer clamp is just out of camera. I'm going to go grab it. Bear with me. All right, I've got my micrometer clamp. So I don't have to hold the micrometer. There we go. And the way we're gonna zero this, we're gonna now have to zero this right on 970. Okay, so we're no longer zeroing on 1 inch, we're zeroing on 970. And then when we go to measure the part, we're gonna measure the difference. So when I drop this on, we're gonna have to pivot this. See the inflection point? It's a little bit harder, right? You no longer have this round surface to kind of help guide you, but it should read 0. So I can't, I can show you again on the secondary camera, I hope. Actually, you know what? I don't think I can. So I've got the anvil inside the micrometer, and I'm just balancing it so that I can try to find the 0. So I'm doing my best, and I'm rotating the dial, and as I pivot, I'm trying to find that inflection point. I hope you can see that. Okay, this is a little tricky. It's one of the reasons I prefer to use a ring gauge. Actually, I think I might have got lucky. Oh, I'm a little bit off. All right. You know what? If I'm this close, I'm not going to worry about it so much. I'm going to be at 1 or 2 tenths off. I can live with that. So now my 0 is at 970, and we're just going to see how far away we are from 0 by dropping it in the part and pivoting it around. So let's look at that on the camera. Right there. As I pivot the part around the anvil, it's pretty much right there at 970. So that's another way to do this measurement, is, which is maybe one of the better ways to do it, honestly, is set it up where you want it to be. It gets a little easier that way. You just make sure it's somewhere in the stroke. You can verify with a caliper that you are reasonably close to where you need to be, and then get your exact measurement down to the 10th that way. So that's the second way to do it. And I think we have time for me to show you a little more complicated, but you may need to know this. So we're going to set this one aside, and we're going to ask ourselves, what happens when you need to measure a larger part? So I did this in the, I measured this part in the training video, but I didn't show you how I set it up. I did go over the math, but let's just go through it. We got time. If you're not interested, feel free to move on to the next video, but I'm gonna have to disassemble this indicator we just spent all the trouble to set up. All right, I need you. And I need my 2 to 6. So, jumping ahead of myself. First thing I'll do this time is I'll put the indicator, just attach it. I won't engage it yet. And then we're going to think about how we're going to approach this problem. Okay, so I got the case protector on. Don't have an anvil in yet. I'm going to pull out the anvil set for this size. It's a different set than we just used because it's a different range. So now I've got the set that we need. Okay. And we're gonna need a calculator. So go ahead, grab a calculator, grab a piece of paper, whatever you feel you might need. Okay, so we have some options. I am looking for the ring gauge. Here we go. The ring gauge that is relatively close in size to the part I'm going to measure. I don't have a ring gauge close enough to allow me to use only one set of anvils. I'm going to have to change anvils. So what we're really going to have to do is set the height of the indicator, pick where that engagement is going to be. And then when we put an anvil on, zero it, we're going to take the anvil out, put new anvils on, and measure. And we're going to use the difference in size of the anvil to help calculate what's going on. So let's do a little math. I have a ring gauge that's 72.037 millimeters. Okay, 72.037. I am going to convert that to inches because all my equipment is in inches. 2.8361. I'm going to round that to 2.836. So let's write that down. our ring is 2.836. Okay, so I'll set that aside. And next up, I'm going to get a ballpark for our part. All right, I don't actually know off the top of my head. And I am going to, once again, find my mark. There's a little R mark. I know this part is out of round, so I want to do this at a place I relatively know. So 3.158, and I'm sweeping my caliper to get pressure and get full engagement. So 3.156, 3.157, I'm going to write that down as my ballpark. And we will see if we get the same result by the time I'm done. So first thing we got to do, we got to pick our anvil that fits. So I said this is 2.836. I am going to try out the 2.756. Drop that on, clamp that on, see if it fits. I get a little bit of engagement, and if you can see from the front camera, it is moving the dial a tiny bit. Not actually. Oh, it's because I have the dial loose. So now that we have picked one, I'm gonna center this. Now that we've actually picked an anvil, we need to center it and make sure that there's actually some engagement. So let's level that on. Is the indicator moving as I rock back and forth? I don't think it is. So yeah. The nub here, when I fully engage, is not touching the wall. That's the issue we've got. So we've got to try a different registration piece. And like I said, it can be trial and error. So if you've got a better way, I'm sure there is a better way. There's got to be a better way. I'm just, I'm not familiar with it. So either way, we should end up to the right. This is way too big, okay? So I'm gonna be able to slide this, but there's no way I'm gonna get that in there. So I was on the right anvil. I just need to add a spacer to extend its range because this range is not gonna work. So I'm gonna try, let's try the 120 spacer. All right, spacer right there. We'll drop it on. And let me take a look first. I've over traveled my gauge. I'm gonna switch the spacer. Actually, I'm not gonna switch the spacer. I'm gonna adjust my dial because I'm over traveling. Basically, the indicator is flipping over to the 0 before I fully engage. So I'm gonna loosen this up and give it the possibility of more travel. Okay, let me double check before I show you guys. Nope, I ran out of travel. So I am going to change the spacer. From the 120, let's try the 40. Or the 80. Let's try the 80. It's not quite as drastic as the 40. So I keep over traveling. I keep over traveling when it goes past 0. So I'm looking for the happy medium right now. And I finally got it. So let me show you guys. On the front camera, you can see it it finds its inflection point right about here. And I'll show you on the main camera or on the secondary camera. It finds an inflection point right about there. So I'm going to try to set my 0. And then let's think about, what are we setting our 0 at? We are setting at whatever this ring is. All right, I've got 0. You have to take my word for it. So our ring is at 2.836, and then we're going to document our spacer. Our spacer is at 80 thousandths. And our anvil is at 2.756. 2.756. These are the nominal numbers that are given by the manufacturer, and I'll show you how we're going to use those. So now we've got 0. We've got it in a range that works for us in 0. And we zeroed it at 2.836. Now when we go to measure our part, we're in the problem of that it's way too loose, okay? So we're gonna have to change our anvil, and we're not gonna move our dial at all. All we're gonna do is change out spacers. So, since our target with the caliper, I got 3.156, I'm gonna put back the spacer, I'm gonna put back the anvil, I'm gonna look at the one that says 3.150. You can see that number 7 says 3.150. So I'll grab number 7, drop it on, snug it up, give it a shot. See if I run into any issues. And what do you know? I'm not running into any issues. I can see, I'll flip it around, show you what I'm seeing. So what I'm seeing is a nice inflection point in the middle of the stroke of the part. So I'll show you this on the second camera. So here's the middle of the stroke. All right. Now, forgot a step. This is part of why it's tricky. So what we need to know, what I forgot to record, you could probably go back on the video and check. What I forgot to record is where the second anvil is relative to the 0, right? So we still have to do that even though we're changing anvils. I don't remember where 0 was in the stroke. I don't know where it is now. So let's record where it is now before we move away. So I am going to take a look at where the anvil ends, where the secondary dial ends, and I will record that on the whiteboard. So, oops, let's see. So it's right about, where's the inflection point? Right about there, around that 2 there. So let me record that. So the secondary the secondary dial is about 20 thousandths, and then 22 thousandths. So I'm going to write that down. So what does 22 thousandths look like? I'm going to manipulate that off camera. 22 thousandths looks like this, where I'm between the 2 and the 3 on the small dial, and I'm at about the 2 there. So that's 22. So I'm going to write that down, and I'm going to write down what anvil I've got now. So let's write down anvil 2. And that was 3.150. And where our reading 2, we'll call it 2, is 22 thousandths. Now we've got to switch back to our zeroing spacer and anvil and record reading 1, which I should have done. Wasn't paying attention. So we had the 2.756 and we had the 80,000 spacer. So number 5 there and the 80 thousandths. Hopefully we're back to 0 after all this changing around and messing about. Grab my ring gauge. Let me verify it off the camera before I show you guys. All right, we're just about there. So I'm going to try to show you guys. And you see there's an inflection point. There's an inflection point, if I can get this right. Sorry. Right about there. So it's, and where is that secondary dial? Let me take a look. Where is that secondary dial? That secondary dial, when it's reading 0, is right about halfway between 0.01 and 0.02. So let me write that down. All right, and we're going to do some math. Just verifying that I grabbed the right pieces. Okay, so let's do a little bit of math. So our ring gauge, when we set our 0, was 2.836. And we're going to subtract what we took off. So we took off the 80,000 spacer. We took off the 2.756. And we're back to 0. Okay. Then we added the 3.15. Okay. And then we added the 0.022. Sorry, I should be showing it. Let me start this over so you can see on the camera. So we took our ring gauge, 2.836, and then we subtracted 80 thousandths. Right, we took that piece off. And then we took off the 2.756. Okay. Oops. So we end up at 0, right? That's a sandy check. So what we zeroed on and we took off the spacers, we're back to 0. Then we're going to add the 3.150. Okay. And then we're going to add the 0.022. So 3.172, and then we got to talk about the difference. Where were we at the 0? And then where were we at the measurement? So at the 0, I said I was about halfway between 0.01 and 0.02. And at reading 2, I was at a little bit past the 0.02 and 2 thousandths. So the difference, the difference is about, what, 15 thousandths or so. So let me subtract 15. 3.157. And 3.157, pretty much what I measured with the caliper. So I don't think I did this quite right, doing it on camera and making that little mistake. But here's the moral of the story. The moral of the story is you can zero on a different ring and change your anvils. If you do it right and you're careful about setting your zeros, you can zero it, change your anvil, and then measure it. So off of the new anvils, you just got to track how far did your indicator, your small indicator here, how much did that small one change when you change the anvils. So it was zeroed at 2.836 on this ring. I changed the anvils to read 3.150, and then the difference was about 15 thousandths. So when you subtract that from what you see, you get to the reading you're looking for. So I hope that's clear. I hope that that's probably the harder way to do it. I recommend you set up on something that's close and double check yourself with the calipers. So anyway, I hope you enjoyed this video, and please please check out my other videos, especially in the hole inspection series. There's a number of them. We've broken this up into multiple pieces, and I want to thank you guys. I want to thank the Laney Machine Technology College for providing some of the parts and the tools. Definitely couldn't do this without their support, without them providing the equipment. So I appreciate that. They have a great program for manual and CNC machining, inspection and quality control, dimensional metrology, CMMs, CAD programming, mechanical drives, and many other manufacturing related courses. They have certificates that you can use to advance your career. If you get through all the coursework, you can add that to your resume. They know people in industry. They know they're connected to the local companies who are hiring, and they're usually very interested in the Laney College's students. So check out Laney College in Oakland if you're in the Northern California Bay Area. And please check out my website, pragmaticmetrology.com, for more videos. And feel free to share your experience with the dial bore gauge. As you can see, I was definitely struggling. Not something I do all the time. So thank you, and I look forward to seeing you for the next video. Thanks.